We are going to go ahead and take a look at number 63 from section 7.1, review of solving linear equations and inequalities in one variable. Number 63 reads -2 is less than -b plus 3 is less than 5. The goal is we want to solve for b, and then we want to provide these results in interval notation and graph it on a number line. So we treat a compound inequality, in other words, this inequality is, in this instance, wedged between two values. That provides a context clue that says that our value is going to actually range from a small value to a large value. So it's going to have the sandwich effect when you graph it on its number line. Your approach will be the same as you would deal with any equation or equality or inequality. So the first thing that we want to do is, in order to get b by itself, we're going to subtract 3. And note that you want to subtract 3 from all three sides. In doing this, we are starting to get b by itself. And also, a common error that you want to avoid, I've seen students in the past, they'll try to eliminate one of these sides so that they try to make it look like there's just a left-hand side and a right-hand side. It's very important that you don't do that. Because you're actually truncating some of your values, or in this case with an inequality, you might actually add on a bunch more. So this becomes -5 is less than -b is less than 2. And then finally what we want to note is that this -b is actually a -1 times b. So we're going to divide all three sides by a -1. Okay. This will cause that to reduce out. But one other thing that we want to be aware of is when we divide by a negative number, the direction of our inequality signs are going to change. So we have a -5 is greater than, b is greater than, oops, sorry, that should be a +5, right, because it's a negative divided by a negative. +5 is greater than, b is greater than -2. Okay, so the presentation is a little bit off, but essentially what I want you guys to kind of imagine is that I'm rotating this, okay? So like I'm going to go this way, and then I'm going to bring it around this way, okay? And act like b is this fixed point. So when I rotate it, I really have -2 is less than b is less than 5. Notice that now I have my smallest value on the left-hand side and the +5 on the right-hand side. And I do have this sandwiched effect. You know, if you kind of read this, well, -2 is less than b is less than 5. If you kind of take that middle portion out, that variable, -2 is less than 5. So I'm getting true statements here. Okay? The only reason why you would write it like this is maybe because you're a little bit more comfortable reading it in this way. So then we would move to our number line. And then again, just arbitrarily note where -2 and -5 would be. And then from here, we would note, all right, I'm going to use parentheses over these because I'm using a strictly less than inequality sign. And then notice as well that my shading is going to happen only in between here. Okay, if I pick any value in between -2 and 5 and substitute it in for b, I would get true statements out. So if I picked, I don't know, -1, this is a true statement. If I picked 0, -2 is less than 0 and 0 is less than 5. That's true. If I pick 3, -2 is less than 3, 3 is less than 5. These are all true. However, if I start picking values outside, so say I pick a -6, -2 less than -6 less than 5, this part is true, but this part is not. Okay, and again, if I were to pick something over here like 11, -2 is less than 11, but 11 is not less than 5. So that's why I don't pick any values outside of that sandwiched area that I've shaded. Okay, and then lastly, we would want to note the interval notation. And in class, we talked about how this essentially just drops down. Okay, this provides me my range. I can start working with any value right before negative 2, going all the way up to 5, and just ending right before I get 5. So what I'm going to box is my final solution.